King of broadcasting on Zoom too.
Okay. You'll be on TV tonight, all right?
He's getting really good at that.
Not many.
He's the Zoom man
Small
for the
audience, yeah.
chapter.
Cool. You guys get quite a few that.
What's that?
I was curious.
We got diehards.
You got some
about
diehards
4 or
that want-
5.
Yeah, yeah. There you go. Nice. Well, some of these guys probably, it'd be a long drive for them to do this.
Yeah, some of them we covered half the state.
Yeah.
Then we had people down in Oregon and all almost died of.
Yeah.
Yeah, I was telling that. James, this is my chapter that I belong to, but I'm almost 4 hours away, so don't make a lot of meetings.
I'm very surprised they don't have one closer to Spokane.
Yeah, I don't know why. You would think Spokane would maybe try to put one together, but.
Yeah, but make it.
I believe so. Never know, man. He's very busy. I almost didn't make it.
What's that?
So I almost didn't make it.
Oh.
Yeah.
It's that time of year too.
What's that?
It's that time of year too.
Yeah.
It's really, really,
A couple weeks away, harvest starts.
yeah, you guys are rolling here soon. You work with Glen Weston too, Shane, or
No,
no?
we kind of bounce around.
Okay. I got a couple of giveaways, so you want to put your name on one of these, that we can, I'll throw them in a hat and we'll raffle them off. And,
Okay.
yeah, that's fine. No, thanks. That's who's the president of the chapter now?
Dan,
Dan is, okay. Oh, Dan, okay. That's right, I remember now. Yeah, I haven't been here since Dan took over. I've been here a couple times. Will was running it.
He moved to Texas.
Yeah, he's down in Texas.
I guess he enjoyed it.
Yeah, that's what he said. I saw him in, it was in R.E.T.A, the national convention, in Jacksonville. I talked to him for a little bit. He said he liked it, so. It's good. Yeah. Well, that's one good thing about this industry. You can pretty much get a job anywhere.
Yeah. You too.
you guys make your own adiabatic coolers?
Yeah, we do. Yep, we just started, we've had the product line out for, maybe 4 years now, but we fully launched it, this year at, the IR show in, yeah, in Orlando, so, yep. Yeah, that's a great, it's taken off big time, adiabatic, so this is a really good.
Still have a hard time understanding.
Yeah,
but
it's a little bit of magic, but I mean, but it's just, yeah, I don't even know. I don't even fully understand the thermodynamics behind it, but it's like PhD level engineering stuff.
Yeah, it rejects heat, but it absorbs heat, but doesn't physically remove it.
Yeah,
It's
yeah,
like,
yeah.
oh
I
man,
know, it's really weird. It's weird stuff. It has to do with the ideal gas law and
yeah, it's like that.
pressure changing and volume changing, and yeah, it's complicated stuff.
And it's like transcritical on the CO2s, obviously.
Yeah.
All right, it
Yes, sir.
works.
Yeah, yeah.
How are you today?
Sign it. Yeah, I forgot I was running around for 8 minutes and I needed one.
Oh, it's working. Yeah, that was, you know, that one for you too.
That was fine. How about your?
Yeah, no problem. Yep. Yeah, I think there's some kids over here too.
Put your name on it and you Travis.
It's- When I go to present, you want me to share it on Zoom or do you just use the camera? And I mean, I can do it either way. It doesn't matter to me.
You can share it with them.
Like I can share my screen on the Zoom meeting. And then it won't like, it'll just show the presentation. It's
Yeah.
easier for people to see. Like I can I'll show you what it looks like and see.
But you can.
Oh,
send
you
that.
guys make.
That's what yeah, I can't.
Oh, you have to disable it, so.
Actually, what I should have done is when we were communicating, I should have asked for the PowerPoint so that I could. do it.
Oh, yeah.
I'm getting, well, I'm learning.
No big deal. Yeah, no, this will work too, so it's all good.
Well, I think you're the first one that's had a PowerPoint for a while, so
Oh,
I never
okay.
asked.
Yeah, no worries.
I can see everything.
Yeah.
A little blurry, but.
Anybody on there yet?
Yeah.
Got a couple of you guys join. Yeah.
We're still talking about doing something for boat races.
That I'm not sure. I haven't heard nothing else since then.
You know, we were throwing around the idea of it.
Well, I'll be gone. I'll be gone most of June anyway, so I'm gonna be able to make, well, yeah, it is towards the end of June.
They still have are you talking about the hydroplane
Yeah.
races? Oh, cool. Do they still do like the big boys, like the super modified, or what do they call those?
The old vintage ones?
Yeah, or like the big ones, like Miss Budweiser and.
Yeah, I think it's Miss Alberta or Miss Alberta now.
Miss Alberta, yeah.
Yeah.
I've always wanted to come see, we used to watch.
I think
So-
they're F1s or H1s.
Yeah, the big, yeah. So when I was growing up, I grew up down in Lewiston, Clarkston area.
Oh, okay, yeah.
And they would, on the Snake, it wasn't wide enough to do the big boats. So we never got to see them, but we used to watch the smaller ones. And I always wanted to come down here to the Tri-Cities and watch them on the Columbia race. Because back when I was growing up, like Miss Budweiser was like I don't know. Like they just owned that division and like they won it like 20 years in a row or something. It's crazy.
Yeah, they were still doing it when I was a kid. I'm not
Yeah.
even sure when they just here, cause then Miss Budweiser came around
Yeah,
for a while,
yeah.
and then, I'm not even sure when Alberta came in.
Yeah,
It's just, it's been around. They still, those are H1, so they're still here.
yeah, that's cool. I'd always wanted to see. I need to come down sometime, bring my boys down. They'd like it a lot. Be cool.
Coming up real quick.
Yeah. Yeah, that's awesome. Yeah, it's wild when they flip those things. That's,
And just the way they propel. man.
I know, then they're
Very-
just skimming across the water. It's just like, man, yeah, a little wind or whatever, and you can just flip them so easy.
We're able to turn that way.
I know, yeah, that's why.
Hopefully there's a lot on Zoom.
Hmm?
Hopefully there's a lot of people on Zoom.
There's 3 of us, 4 of us, family guys. Yeah. Hey, how you doing?
Hey, how you doing?
Been a while.
Been busy. Yeah, been busy.
I'm Todd. You want to put your name on there? We're gonna raffle off some cake stuff at the end. Your name is Todd? Todd, yeah. Nice to meet you. Thank you. Thanks.
I guess that's what I was spending.
Yes, sir. Thanks.
Wait, can't you, you're in there, right?
I'm in it, yeah.
Can't you take control of it? over
Yeah,
there?
well, I tried to share, but it said that it was disabled, the host is disabled, so I don't know if you can.
Oh, yeah, let me check that out.
Is that mine? That's
I'm still learning off.
Oh, it's all right.
Hey,
I'm not, I don't use Zoom very much.
here,
but-
guys, I mean, yeah, I'm using Microsoft Teams and you can just.
Yeah, that's the way I am too. Oh, now it's letting me, okay, so.
Okay. Cool, you guys will be able to see a PowerPoint.
Yeah, so.
There you go. sir.
Things?
No problem, sir. How's everybody?
Everybody.
Awesome.
Well, let's see on from the side. That's cool, thank you for that.
Yeah, no problem. No, that might be easier for the people online to see a little bit better.
Roger, well, still kicking.
Still there. Called in today.
Uh,
Jason called in. It's 6, so he called in. Roger called in. I'm like, what the hell going on? Everything's sitting down.
Sun's gone around.
It's not. Fish. It's not hunting season.
We're still looking for more operators.
That's what we're for. Who quit?
We've been short, but then we had trainees in, but they didn't put out.
So we're trying to run with two share.
So, 2%. Then we're
It's a
trying,
good idea, if you get some people.
yeah, we're trying over 10 for right now. And then we're planning on going to the 12-hour shifts.
I thought that didn't work out.
It's already in place, but we just don't have the people for it. That way the whole plant hasn't changed over to a 12-hour shift yet. Yeah. So it's already in the contract, the new contract. But it's been delayed because we can't find anybody to work
It's too far out for the money.
in all the departments. We don't have enough people. There's in the department.
I know they want to put the maintenance in on the refrigeration, but still. From the Tri-Cities, and the same money.
Yeah.
Yeah, was
Especially
it
if-
Gordon or Condo?
I know.
Condo.
You gotta go all the way out there on the roads, and it's the same money as down here. It's been that way for a long time. They up the wages, but still,
Yeah. Going competitive if you live in Condell.
Yeah. Yeah.
If you're driving all the way to Condell, try to say it's not competitive.
Yeah. Better against the prison.
Yeah. And I think Pete might be leaving us. Pete, yeah. Pete too. Yeah, I've been hearing, and I've been hearing rumors that he's been living in, the other,
These details are all right.
the BNR for Pete Terrace. He went to the meeting a couple times.
Oh,
Yeah. Yeah.
we can go.
Yeah, he took 2 weeks vacation, and then after that, I've been hearing rumors that he found a job when he back. Yeah, yeah,
Oh, Roger's about ready to boot too, isn't he?
I think so. Losing guys, that's all right.
Yeah. Sounds good.
Trained a couple guys, they didn't cut out, so they didn't want to stay in the area, they end up going other places to go talk to the ladies. Nope, out of here. Like, we can't have y'all for your DNR, if you don't not be in your area.
Been most of the time in the lab. That was going on when I was still there.
Yeah, this is when this guy was training to,
And he was still in the lab.
yeah, he called so many times, like, hey, you can stay in your area. After you talk to him, how are they? You seem like in the lab, you know, what the fuck?
Well, yeah. Well, Jerome used to do that famous though. Only here 10 minutes. That was an hour ago, dude. There you
You got probably all that show.
You ready to go? Okay.
Up to you.
Just want to make sure. Yeah, no, I'm ready anytime. So, yeah.
Yeah.
So, all right, cool. We'll get started. So my name's Todd Sheldon. I'm a sales manager at Colmac Coil. So been with the company about 13 years. So I really like this industry, and this chapter kind of holds a special spot in my heart just because I belong to the chapter. So I always like coming down here and doing presentations. So thank you guys for inviting me to present to you tonight. So we're gonna talk about adiabatic dry coolers and condensers. So you guys may or may not have seen this. You might have installed one of these pieces of equipment, might have them at your facility, but this is kind of a newer piece of equipment that's coming into the industry. It's been in the HVAC world for quite a while, but it's starting to make its way into industrial refrigeration. There's a lot of advantages to why you want to use adiabatic dry coolers and condensers, and we'll talk about that tonight. So what does adiabatic mean? It's kind of this weird word that we don't really know what it means, right? So I was talking about this with Shane. It's kind of magic how it works. But what it stands for is occurring without loss of gain of heat. Loss or gain of heat. And so the basic principle is as the warm air encounters a wetted pad, the air temperature is reduced adiabatically. So that's a thermodynamic principle. Allowing sensible cooling of the air below the ambient driver temperature. So let's define a few things here because we're going to be talking about this terminology throughout the presentation. But so dry bulb temperature, That's just the temperature of air measured by a thermometer, freely exposed to the air, but shielded from radiation. So if you have a thermometer in the shade, that's the temperature you read on that thermometer. Wet bulb temperature is a little trickier to measure, but that's the temperature you read by a thermometer covered in a water soaked cloth over which air is passed. So there's some, I can't remember what the device is, but I think it's called a sling. It's basically a thermometer and you swing it around the air and it's wet, it's got a wet cloth over it. And that's how they measure wet bulb. And then we need to talk about wet bulb depression. And wet bulb depression is the difference between the dry bulb temperature and the wet bulb temperature. So humidity, I think most of us are familiar with humidity. You know, you feel it on a warm day when right before like a rainstorm, you can feel that really heavy, thick air that's wet. And humidity is the concentration of water vapor that's present in air. And then relative humidity, you've heard that. Then people talk about that like on the news when they talk about the weather. It's usually they usually express it in a percentage, and it's just an indication of how much humidity is in the air versus what they can hold at saturation. So when they say it's 50% humid relative humidity, that means that air is half of the amount of water vapor it can hold. So the mean coincident wet bulb, that's the average wet bulb temperature at the same time as the coincident peak dry bulb temperature. So explain that better. On your hottest hour of the summer design day for your piece of equipment, the mean coincident wet bulb is the expected wet bulb temperature you'll expect to experience at that time. So let's talk a little bit about how an adiabatic dry cooler works. So when the outside air temperature is below the dry switch point, the unit operates as a dry cooler. So there's no water flowing over the pads. It's just cool air blowing over the coil and either cooling fluid like glycol, or it's condensing a gas like ammonia. So that's just using cool air. And at some point you're going to switch over. So once you get to where that dry switch point, you're above it, then the water turns on and you start wetting the pads. So usually you run your fans all the way up as fast as you can move on the airflow until you're not cooling any more cooling. And then at that point, that's when they call the dry switch point. You start putting the water over the pads. And this allows the unit to reject heat so when you have the wetted pads, you can pre-cool the air to about 80% of the wet bulb temperature. So that's the advantage of doing adiabatic cooling is if it's 90 degrees outside and the wet bulb 70, we can get to 80% of that 70-degree temperature by wetting the pads down to that wet bulb temperature. And that allows us to reject more heat even on hotter ambient conditions. So hot air, so most adiabatic dry coolers are like in a V-bank, so you can see how the coils are kind of in a V arrangement. And in our design, we do straight pads straight up. So it's hard to see that underneath the pads are actually, the coils are banked in a V. But so hot air goes through the coil and then up through the fans at the top of the adiabatic cooler. Water is only used during the hottest part of the day and in the year. So in some applications, your annual water usage can be reduced up to 80% compared to an evaporative cooler or evap condenser. So that's the real advantage there. If water is expensive or scarce, that's where these really shine. So adiabatic dry cooler, the difference between the dry bulb and the wet bulb, the air is a key performance factor. So that's kind of how you can determine how efficient your dry cooler is, your adiabatic cooler is. And so the difference can vary between the dry bulb and the wet bulb between 0 to 40 degrees, depending on the weather conditions. So obviously the drier your air is, the more potential there is to carry water in that air, and then the wet bulb is even lower. So you can find ASHRAE weather data for your area, and it'll tell you what the max temperature is in your area, and then also what the wet bulb is at that temperature. So air has an affinity for water, so it wants to absorb water, right? And so we see that in drier climates where it evaporates really quickly, right? So the drier the air is, the more moisture it can absorb. So just for an example, at 90 degrees Fahrenheit with 30% relative humidity, air can lose about 20 degrees Fahrenheit if it's saturated with water up to 85%. So that's a pretty big advantage, right? And those conditions are pretty common in this part of the world, right? So as you can see, this map that's on the screen is showing relative humidity, average relative humidity. So you can see that basically kind of from the central part of the United States west until you get to the coast, you're in prime area for putting in an adiabatic unit. Other than Nevada, which is basically that red kind of oblong spot you see there, that is the best conditions. And then the next best condition, you can see the orange area and how it goes clear up in eastern and central Washington. So this is a really good climate for using adiabatic. So another example, so if you have an area that has a higher relative humidity, say you're on the East Coast and it's 90 degrees and it's 60% relative humidity, or you're in the South, then the air only has the ability to lose about 10 degrees F if it's saturated with water up to 85%. So you can see how that humidity really makes a difference and how much you can use that wet bulb to cool the air that's going into the adiabatic cooler. So this means adiabatic dry coolers obviously work better in climates with lower relative humidity. So what's an advantage of an adiabatic cooling system? It has very low water consumption. So we were talking about that. We're much less water than an evap condenser or a evaporative cooler. You can operate it most of the year in dry mode, so you're not using water. And then the other big advantage is you don't have a sump to maintain or water treatment that you have to use. So water treatment can be a big hassle if you're not familiar with that. But so you can see this map shows water prices in 30 major US cities. And this map is basically showing that it's a family of four. The cost of a family of four using 12,000 gallons of water a month. So it can get, water usage can get really expensive quickly. So all adiabatic pads require some amount of water overfeed, right? So the more water that's sent to the pads, or more water is sent to the pads than what is evaporating. So you're saturating the pad. It's not all evaporating. There's water that's going to be that doesn't get evaporated on the pad. So there's lots of different ways that people are doing adiabatic cooling. Some manufacturers use a large sump with electric pump to recirculate the water. That's one way. Another way is some manufacturers are just soaking the pads. They're just putting water over the pads and then they're just putting the water down the drain. They're not recirculating that. And then because of these different methods, there's a wide range in the amount of water usage depending on what type of system your adiabatic dry cooler is using. So our system, the way we design adiabatic coolers is we recirculate water without an electric pump. So we use a device called an eductor, and we'll talk a little bit about that. So one advantage there is it's a reduced water usage compared to a one-stream design. So we're dumping some water down the drain, but we're also recycling some. So there's a little bit of makeup water and there's a little bit of bleed off water. The nice thing too about an eductor is it's not a pump. So you don't have electric costs, you don't have pump costs. So your maintenance costs due to not having the sump and electric pump are less. So here's just a diagram of our system and how a piping diagram for the adiabatic cooler. So you can see at the bottom of the diagram, the makeup water comes in to the piping, right where there's a T where the recirculated flow rate comes back. That's where the water is being pumped out of the sump from the eductor. So right where that T is where the inductor is. That circulating flow rate goes back up to the top of the adiabatic cooler, and then half of the flow rate goes to one side of the pads, and then the other half goes to the other side of the pads. And then that water just drains off the pads, goes down into a sump, and then any water that doesn't get pulled up in the heat duct gets bled out through the bleed water side. So just for an example, if we're looking at a 3-inch pad, so the pad depth is different depending on what you're designing your adiabatic cooler for, and we'll talk some more about that here in a little bit. But for this example, we're going to talk about a 3-inch wetted pad. The dry switch point is 74.8. The air velocity over the pads is 522 feet per minute. The circulated water flow rate, so the whole water flow rate over both pads combined is 28.2. We're making up 14.8 GPM flow rate, and then we're bleeding off 3.7, and then we're evaporating 11.1. So if you add up the 11.1, 3.7, and 14.8, that adds up to your total to 28.2 GPM. So the eductor, how does that work? So an eductor uses pressurized makeup water, comes into the eductor, and then through the pressure nozzle, it produces a high velocity jet. And so the high velocity jet creates a vacuum, and then that vacuum sucks water out of the sump. And then that will flow up into the body of the eductor, and then it's entrained in the liquid that's being put over the pads. So the one thing about an eductor is it does require a minimum feed pressure. So if your feed pressure isn't high enough, then it's not going to work. But it's usually doesn't take that much feed pressure to make it operate correctly. Obviously, the lower the feed pressure, the less water is recirculated. So the higher that velocity is going through that jet, the more suction it's going to have, and the more water it's going to pull out of that sump. So it's better to have more water pressure than possible. So what's the advantage of an eductor? It's a low initial cost. It's just a fitting that's in the line. It's not a pump. It's self-priming. There's no moving parts, so there's maintenance advantages there. Easy to install, replace if it's damaged or broken. It doesn't require any additional electric energy, so it's not going to be consuming power, so you don't have that parasitic energy loss there. So there's some advantages. The dry switch point, we talked a little bit about that, but just to define that, so that's the outdoor ambient temperature where operation the dry cooler is no longer possible, and the pads need to be wetted to pre-cool the air. So usually with most dry adiabatic dry coolers, that point is where the fan is running, all the fans are running at 100%, and you can't get any more cooling out of the air. So you have to, at that point, start putting water over the pads to get more cooling. So cycles of concentration, that's important in adiabatics because you need to have a certain amount of flow over the pads. So that definition is it's the makeup water flow rate divided by the bleed rate flow rate. So in our example that we had before, our makeup water rate was 14.8 and our bleed water rate was 3.7. So that would mean we have a cycle concentration of 4. So as we just spoke for talked about cycle concentration is the ratio of the makeup water to the bleed water. And the higher the ratio, the more minerals are being concentrated in the recirculated water, more minerals build up on the pads, which means more frequent pad changes. So that's why cycles of concentration is important. And you might have to adjust it throughout the year, and also depending on the water quality. If you have bad water quality, then you're gonna have to adjust that cycle of concentration. Typical cycles of concentration is 1 to 4. So we'll talk a little bit about the adiabatic pads. They're kind of an interesting product. So the type that we use is called the Munter's Wet Deck. Kind of looks like corrugated cardboard, basically, but it's similar to that. It's a cellulose board. So it's, I don't know I don't know if it's, made from trees or if it's, or what kind of cellulose it is, but it's probably some kind of wood product, I'm guessing. So the thing about the Munter's wet deck, the advantage of it is it wakes up moisture really quickly. So you're always keeping that pad fully wet, which means that you're gonna get immediate cooling if you have that wetted pad. It's treated to resist deterioration, so it is treated so it doesn't degrade and just deteriorate over time. It's designed to have a low air pressure drop, so that means that you can use less fan horsepower, save energy there. It's got cross fluting and unequal pad channels, and that just helps promote cooling. So just the way they design the padding, the way the air flows through it, it's optimized. It's a self-cleaning design because they use really steep angles and the flutes of paper. So maintenance, what do you need to do for maintenance for the pads? So weekly, you should inspect the pads for bowing, sagging, dry streaks. If you got dry streaks, it means you're probably not putting enough water over the pads, which is bad because it means you're probably going to be depositing more minerals and things like that, which will destroy the pads quickly. You got to check your water distribution system. So there's a tray over the top of the pads and look for any leaks in the trays, any clogged holes. So that can also be a reason why you're not getting water over the pad. Could be just not enough flow, but it also could be that you have a clogged hole in the tray. Monthly, you should check the water flow and adjust it if necessary. So as you go through the different seasons, and as you know, the humidity is changing over the months and things are getting cooler, you might need to adjust your flow rate throughout the year. And then pad replacement yearly, you're going to probably need to replace the pads. You might have to replace them more than once a year, depending on the amount of runtime you're running in adiabatic mode, and then also climate conditions. They can be filter or magnets for all kinds of stuff, you know, like could be cottonwood coming off of the trees, getting sucked into there. They can act like a filter. So and then also water quality. If you've got bad water, you're gonna have to change the pads out more frequently. So
On the water flow rate,
yeah.
are you throttling a ball valve or some kind of valve, or are you, was it on the E-ductor?
Yeah, so it's,
Linear jet flow.
yeah, it's the e-ductor. So we'll look at it in here in a little bit. We actually have some flow meters that we've installed on the adiabatic coolers, and you can adjust the flow. So you'll be able to see what the flow rate is. Then it can change. But we also put a pressure regulating valve, so that helps to make those flow meters work correctly. So to wet the pads properly, you need about a gallon and a half per minute per square foot of the top of the pad wetted. And then the water flow rate and water temperature don't really have that much effect on any adiabatic pad performance. The main thing is you need the entire pad being saturated and wetted. That's the important part. And that's where you're gonna get the best performance if that pad's fully wetted. Pad depth does have an effect. This is where we're going to talk about the different pad thicknesses. So an example that we saw earlier, we were talking about a 3-inch pad. So the advantage of a 3-inch pad is it uses less water and less fan horsepower, but you don't cool the air as much as you do with a deeper pad. With a 6-inch pad, you use more water and more fan horsepower, but you can get closer to that air, that wet bulb temperature. So you can get better performance out of your adiabatic cooler, but it just depends. So you're trading one advantage for the other. Now you're using more energy, but you're getting better performance on your refrigeration system. So it's kind of a trade-off. You might be using more fan horsepower, but you might be using less energy in your refrigeration system somewhere else because you can run your head pressure at a lower temperature or a lower pressure. All right, so let's talk a little bit about the piping. how we do that. So, you can see in the photo, there's a couple different devices we have there. So, Shane, you were asking about the flow meter, so you can see there at the top of the picture, there's a flow meter. We have a three-way valve. There's a pressure, water pressure regulator, a bleed water, outlet, a freeze valve, and then a sump. It's a really small sump. So, the sump that we have, has a bleed water outlet, so we are bleeding off some water. In the sump, we also have a suction port for the eductor, so that tube coming up out of the sump there, right here is the where we're pulling the water out of the sump into the eductor. There's a drain port with an automatic freeze protection valve, so when you're in those swing seasons where you're freezing maybe at night, but you still need some adiabatic cooling during the day, the sump will drain if it's below 37 degrees. And then we factory set the inlet water pressure regulator at the 50 psi G. And it also has a pressure gauge. You can see that there in photos. You can see what pressure the pressure regulator valve is set to. The three-way valve just controls the flow of the water. And so if it's off, there's no inlet water, and then the system drains entirely. So this is a free draining system, at least up to the adiabatic cooler. So it'll completely drain. You don't have to worry about freezing at that point. And then if it's on, the water flows through the adiabatic cooler and over the pads, and the drain is closed. And then we talk about the flow meter, and that's where you can use the flow meter to adjust the flow rate seasonally. So what's some of the advantages of this type of setup on your system? It's a low maintenance design. The sump doesn't freeze because you have the anti-freeze valve, and it'll open at any temperature below 37 degrees. So you're going to drain several degrees above freezing. The main water feed line does need to be heat traced. So that's one thing. It needs to be insulated and heat traced so it doesn't freeze. And then if the main line is turned off and drained, then you also need to drain the pressure regulating valve as well so that it doesn't freeze. We'll talk about a little bit about the controller. So it's a pretty basic controller, which makes it easier to operate. It's just a Corel PLC. You probably seen Corel controllers on other types of equipment. It's pretty common controller that's been used in a lot of different industries, HVAC, that's refrigeration. So all the factory we factory wire the sensors to the unit. So, and on our units, we provide a fluid outlet temperature and pressure, and then an ambient temperature. Fans, the controller can control the fan speed from 0 to 100%, and it controls the water valve, so open and close the water valve. We can also take run signals either from your control system, through a contact through your control system. You can put a schedule in there and run it off the schedule, or you can just manually go up and turn stuff on and off at the controller. So there's several different types of modes in the controller, and we'll talk about these different modes, but there's a water saving mode, an energy saving mode, a daily run schedule mode, there's a dry out mode, and then there's a manual mode. So the water saving mode, the advantage of that mode is unit will run with less water usage. So in that mode, we ramp the fans up typically 80–90% before we start turning the water on. It's adjustable, so you can select that range, but that's where we typically set that up for the factory. It prioritizes using the fans to their maximum airflow before we start turning on the water. So that's why it uses less water in this mode. So the disadvantage with that is you're going to use more fan power, but you're going to use less water. So an energy saving mode, you'll use more water consumption, but your fan power is gonna be less. And in that mode, what we do is we run the fans up to like 30 or 40%, and then we turn on the water. So we turn on the water much sooner than when the fans are ramped up full speed. So the advantage of that mode is that you're using your adiabatic water supply to reduce the fan power consumption. So if you're worried about energy and not as much about water, this would be the mode you would want to use. You can also set up a daily run schedule mode. So if you don't want to use the energy saving mode or the water saving mode, you can put a schedule in the controller, and it can be that schedule can be activated by either a control system or just by a contact being turned on and off. There's a drought mode, and that's important because it's usually can be user selectable or it can be scheduled. And it forces the fans to operate with the water valve off throughout the pads. So it's important to drought the pads, and you need to do this at least once a day. And it's because if you don't, you'll start growing stuff on your pads, and so you get fungus and mold and different things. So you gotta drought those pads every day, let them air out. Manual mode. So if you want to run your adiabatic cooler manual mode, you can just walk up to the controller, turn it on. You can test the fans, you can open the valves, shut the valves, and in that mode, it ignores all the sensors on the unit. So you're basically just overriding everything, and you're just controlling it manually. So the controls in the display are factory mounted, and it's in an EMA 3R enclosure. Controller setup and training is available. You can we do it online just like we do here, like on a Zoom meeting or whatever. And then we also do the factory startup assistance as well. It's available. So we haven't talked much about the coils yet, but you can see here a little bit better. This is how a unit would look before you have the pads on it, before the fans are installed. So you can see how the coils are in a V configuration. There's a lot of different types of coil construction that you can do. So the main two types that we offer is a stainless tube, which is what you would use like in ammonia. You're going to do an adiabatic condenser for ammonia system. And then we also offer copper tubes, which is what you would use if you're doing a water or glycol system. We have lots of different fin options. So depending on, it's not really a problem in this area, but like if you're on the coast or someplace where you've got salt and corrosive stuff, you might want to use stainless fin or epoxy coated aluminum fin or even a copper nickel fin. But typically, probably in this area, you're going to mostly see an aluminum fin, what you can see. The default casing is galvanized steel, and it's G235, which is a really thick. So it's a steel with a really thick galvanized coating, and then there's also an option for stainless as well. So if you get a stainless tube coil, we can operate that coil up to 1800 psi. And the reason we designed it for that high of a pressure rating is a lot of these adiabatic units are getting designed for CO2 systems, and they're designed for transcritical gas coolers. And so that's why we need to have that pressure so high for those applications. Construction options that come with that. So if you get a stainless steel coil, you're going to get a coil that meets B315 ASME, so that's just been into industrial refrigeration piping guideline. If you get a CO2 coil, it's going to be UL 207 construction. So we've went to UL 207 or UL and got our coils rated for up to 1740 psi. And then if you're in Canada, we can also do a Canadian registration number as well. So one advantage with this design is we call it, it's 100% parametric, so we can make it as long, short, wide as you need it to be. So if you have a certain footprint that you need to fit, this adiabatic cooler in, you can optimize it to fit in that space. So the advantage of it, the V-Bank design, is it allows for a high density, amount of coil surface, in a footprint, so you're basically putting as much coil surface as possible in the smallest footprint. Some of these are units you'll see, like in this photo, it has a single row of fans, and then a bigger unit, it's only 2 rows of fans, side by side. And then we can build gas coolers up to about 600, or 6,000 MPH. We, on our units, we do AC fans standard. We always use, in ours, we always do vertical pads, so you can see those in the photo. There's straight up and down on the side of the unit. The water distribution trays are cleanable, so if you have any problems with fouling or minerals in your system, we can pull those trays out and clean them. And then there's an access panel for cleaning in between boards as well, so you can get, that's what that red circle is on the screen there. Climb in there and get in there and clean as well. And then we put return bend covers over the tubing in the coil, so that it protects it from something running into the unit. So if you are designing an adiabatic cooler, there is software that is available that we have that you can use to design your adiabatic cooler. So and then there's different criteria you can use if you want to look for the lowest cost, if you want to look for energy efficiency, sound level, weight, certain footprint or dimensions, or if you want to reduce the amount of charge that you're in your system, the software can look at all that. If you're interested in the software, we can give you access to it. It's free, we don't charge for it, and it's available to anybody who wants it. So just to summarize everything here, so like I just talked about, we have software. If you need to design a adiabatic cooler, the footprints are customizable, so you can design your cooler to fit in a certain space. There's multiple pad depths available, so we use 3-inch and 6-inch pads, and then you can optimize your design based on your application, and then also for your climate design conditions. So depending on what's important to you, you can decide which pad depth you need. And then we use the eductor piping system. And the advantage there is we reduce the water usage without the use of a pump. And then back to kind of more talk about the footprint here, we can build an adiabatic cooler with 1 fan or 20 fans. So we built them small, just a little bit here, like just right here in front of this table, all the way up to something that basically fits on the full length of a flatbed semi truck. And then also the other point is we can build a gas cooler up to 1,800 PSI. All right, that's it. So thank you guys. I appreciate your time. And yeah, if you guys got any questions, I did bring some cards. You can take my card. If you run into, one of us down the road somewhere and you need some help with them or any questions, yeah, feel free to call me or email me, and I'll help you with as much as I can.
Have you guys installed some of these or had any users for ammonia?
We have, I don't know if we've done any, so this product line is pretty new to us.
Yeah.
We just launched it at IR in Orlando, in March, fully launched it. We've done some ammonia systems, for units that are on, some OEM packages, like for some bitzers, chiller packages and things like that.
Okay, all right.
We've done some projects for CO2 adiabatic gas coolers. for a transcritical system. But I don't know off the top of my head right now. I can't think of anyone's done yet, but we're bidding a lot of them, so it's a matter of time. We'll land up. But like you said, the product's only really been out for a few months, so. But, yeah,
I'm serious, thank you.
yeah, no problem.
Thank you for coming.
Yeah,
Thank you.
thank you guys.
You heading back tonight, or you staying down?
I'm gonna stay tonight, yeah, yeah. Yeah, I'm staying. I didn't really need to have to be in the office first thing in the morning tomorrow, so. I'm like, didn't want to kill myself trying. 8 hours in one day, yeah. So, that's all good. Perfect, yeah. We're good.
You guys got any question on the Zoom?
All right. Well, since there's only a few of you, if you guys want to take what you want, and then whoever doesn't get something, I will mail them something. I hate to raffle off 3 items for four guys. I'll just give it, I'll just mail them.
No, go ahead, man. Go ahead and take them. I raffled off half my stuff last time.
Okay, whatever, that's fine too, whatever.
Alright,
So,
go ahead and
think
end
what
this
you want.
meeting.
The sweatshirt is,
You guys have anything else on the- Oh, hey, send me your email right now so I can get it. I'm talking.
Oh, okay.
Sorry.
the sweatshirt's an extra large, so,
I don't want to go through.
okay.
There were 3, wait, 4.
If you wanna have
No,
it,
just these 2. Just copy of that. Yeah.
Alright, I'll take that.
You want a sweatshirt or a mug?
Have a little patience. I'll get this
All
to
right,
you
yeah.
tomorrow,
Yeah.
sometime during the day.
Yeah, nice meeting you guys. Nice meeting you, James.
Nice to meet you.
Yeah, there's
No,
some
I'll get it to you.
stuff here too. You guys want there's,
Yeah, just send me the list.
this is our insulated penthouse units.
You go to dinner. You guys have a good one.
Yeah, you too.
Take one of those. Colmac Coil Manufacturing. It's in Caldwell, Washington.
You can get it from David.
Oh, you're from Deer Park.
Don't
Oh,
hit up
okay.
Dan, Dan,
Yeah,
you
we're
can
just,
hit up
yeah.
David, or
just
you can
north
hit
of
up
there,
myself,
so-
Shane, or.
I drove
Shane.
through the Deer Park on my way
Either
down.
one of us can get you.
Oh,
that
that's funny,
PhD
it's small
info.
world.
But I can,
Yeah.
put your email address
Yeah,
right
so
there right
you've
now,
been
man. I
there
can take a
for
picture of it, get it
about
sent to you
50
tomorrow.
years,
sometime.
this company's been in business, so.
Or
yeah.
send to me that I can do.
Yeah, so this one's about the.
Exactly.
Food coolers, this is about our evaporator. line.
Just looking, just.
Yeah,
About.
you just want the food coolers? Yeah, what's this one?
What size is this?
All right,
extra
I got
large.
you, Caitlin.
Yeah,
You know.
Like I said, just have a little patience.
Perfect.
If I do forget tomorrow, go ahead and send that, the LIA,
so that's insulated
LKE,
penthouse one,
at Yahoo
this
email
is
one, to me, and I'll get that going, but I should be
I
able
don't know,
to.
you guys have any notes? Am I looking at?
Perfect.
You don't
All
have
right,
those?
so hop off here, man. You guys have a good one.
And this one's about air condensers, and this is evaporators, and this is